Hello everyone, welcome back to Tales of Chemistry. Today we are discussing chapter Alcohol Phenol Ether for ISC class 12. In that, only phenol is today's topic. This episode includes preparation of phenol, physical and chemical properties of phenol, as well as test for phenol. So, let's begin with the preparation of phenol. Phenol is industrially prepared by Dow's process. This Dow's process we all have studied in alkyl aryl halide lesson as well. That is, chlorobenzene is treated with sodium hydroxide solution. So, chlorobenzene, when you treat this with NaOH solution at high temperature, around 623 Kelvin temperature and 320 atmospheres of pressure, you will be getting sodium phenoxide, benzene ring with ONA, sodium phenoxide. Along with sodium phenoxide, there will be elimination of NaCl, as one of the product you will get NaCl as well as water. I have written here minus NaCl and minus H2O. That means chlorobenzene, when reacting with sodium hydroxide along with sodium phenoxide, we get sodium chloride as well as water. Okay, now sodium phenoxide is then collected, treated with dilute acid. You will now eliminate NaCl. So there is a elimination of sodium chloride, and along with that we will be getting phenol. So in Dow's process, the intermediate is sodium phenoxide, which on acidification, when you treat it with dilute hydrochloric acid, you are getting phenol as your final product. Phenol is your final product. Okay, so the next method of preparation is a very important method. This is again industrial preparation itself from cumene. So let us first see what cumene. This is called the cumene process. Cumene structure is given here. It has a benzene ring which is connected to isopropyl group. Now, what is isopropyl group? CH3, CH2, CH3. Okay, this is propane. When you remove a hydrogen from these two positions, any one of these two positions, okay, that will be a normal propyl group. But when you remove, that is, one second, example for normal propyl will be CH3, CH2, CH2 with a bond. This is a normal propyl. But from the same propane, if you remove hydrogen from the middle carbon, you will get a isopropyl group. And isopropyl is CH3, CH, CH3 with a bond here on the middle carbon. Now, isopropyl benzene is called cumene. Isopropyl benzene, or you can even call it 2-propyl benzene, second carbon of propyl. Okay, or propane is connected to benzene. This is 2-propyl benzene. Now let's see what is cumene process, or how can we use cumene for the preparation of phenol. Now you will have to start with cumene, CH, CH3, CH3 on either side of CH. So this is cumene. Treat cumene with oxygen. Treat cumene with oxygen at 368 to 408 Kelvin. If you cannot remember the temperature, a delta will be enough. Okay, oxidation of cumene takes place. So the chemical process that happens here, takes place here, is oxidation of cumene. And you will get on the carbon, the two CH3s are remaining intact, but between the C and the H, that's the middle carbon, right? So between the C and the H, you will have to insert a molecule of oxygen. So this is also an example for insertion reaction. And the product, which is actually the reaction intermediate, is called cumene hydroperoxide. Cumene hydroperoxide. Now, this cumene hydroperoxide is then treated with plenty of dilute hydrochloric acid at around 323 to 363 Kelvin. And the product that you get is, the product that you get here is one is this. Okay, what is that? CH3, CO and CH3, acetone, and there remains a OH, which will now be connected to the phenol or the, benzene ring. So one of your product is phenol and the other product is CH3COCH3, which is acetone. This is industrially very important because you're preparing two important organic compounds, phenol and same amount of acetone, right? So that is cumene process, one of the important industrial method of preparation of phenol. The next is a general method of preparation from sodium salt of benzene sulfonic acid. If it is SO3OH, it is benzene sulfonic acid, but this is now sodium salt of benzene sulfonic acid, which is called sodium benzene sulfonate, sodium benzene sulfonate. Let's see how the reaction takes place. So, this is our sodium benzene sulfonate that is to be treated with excess of sodium hydroxide at a high temperature around 573 to 623 Kelvin. If you again cannot remember the temperature, make sure that you write a delta. Heating has to be represented. The intermediate or initial product formed is ONA on benzene ring, which is called sodium phenoxide. Sodium phenoxide. Now, sodium phenoxide is then treated with dilute HCl, dilute hydrochloric acid. You will be getting OH, that is Benzene ring with OH, phenol. So this is a general method of preparation from sodium salt of benzene sulfonic acid or sodium benzene sulfonate. Well, the next reaction from benzene diazonium salt. So I will be taking here benzene ring with N2Cl. Now this is benzene diazonium chloride. Benzene diazonium chloride. This is to be treated with warm water. So I'm just writing water here. Warm water. What happens is you get phenol, that N2Cl is replaced by OH group. Along with that, N2 and HCl. So these are the important methods of preparation. Some of them are general methods of preparation and some are industrial method of preparation. So only these many methods of preparation we need to study. Next topic is physical properties of phenol. So you can just note these points. Phenol is colorless, crystalline, deliquescent solid. Its melting point is low, around 42 degrees Celsius. Yeah, need not memorize the melting point. So colorless, crystalline, deliquescent solid with a low melting point. Phenols are slightly soluble in water. This becomes important because alcohols are highly soluble. Right? Alcohols dissolve in water, but phenol is sparingly soluble or slightly soluble in water. Now, let us begin with the chemical properties of phenol. The first chemical property, which we have studied in 11th grade, is reaction of phenol with zinc dust. Phenol, when heated with zinc dust, you get ZnO along with benzene. So this can be asked as how do you convert phenol to benzene? How do you convert phenol to benzene? Treat phenol with zinc dust. Now, action with ammonia. You have studied this in alcohol. The same reaction happens with phenol also. Phenol, when treated with ammonia, in presence of anhydrous zinc chloride and at a high temperature, anhydrous zinc chloride helps in the elimination of water. So OH and H from ammonia is removed as water. So there remains benzene ring with NH2, that is aniline. Therefore, by this reaction, phenol can be easily converted to aniline. Phenol is very easily converted to aniline by treating it with ammonia or heated ammonia in presence of anhydrous zinc chloride. Now, reaction with acetyl chloride. Similar example we have studied under alcohol. So when you treat phenol with acetyl chloride, the H of phenol, okay, H of phenol combines with Cl of acetyl chloride. This is acetyl chloride. And you remove HCl. Along with that, you are getting benzene ring with one oxygen, and that oxygen is connected to COCH3. This is an ester and its name is phenyl acetate. This is an ester, pleasant fruity smelling compound. Now, this reaction tells us about the acidic nature of a phenol. This reaction actually, highlights that phenol can lose its hydrogen, right? And any compound that can lose its hydrogen as H plus is an acid. Now, what is the function of pyridine? Pyridine is a base, so it combines immediately with HCl. Otherwise, the reaction can become a reversible reaction. So you are removing HCl as soon as it is formed with the help of pyridine. Now, the next reaction is action with PCl5, phosphorus pentachloride. Once again, how we have studied this under alcohol. The OH is completely replaced by one of the Cl ions here. So you will get your major product, or your intention here is to prepare chlorobenzene. Okay, so you are removing that OH completely and replacing it with a Cl from PCl5. What will happen to that OH then? OH combines with the remaining part of PCl5 to give you phosphorus oxychloride, POCl3, along with that HCl. POCl3 and HCl are the products. Now, the next reaction is reactions that involve the benzene ring. Reactions that involve the benzene ring. Okay, so the reactions that involve benzene ring, first one and a very frequently asked question is bromination. Bromination of phenol. Now, phenol is treated with bromine water. So how do I write bromine water? I can write it as Br2. Okay, Br2. I need 3 molecules of Br2. Here in bracket aqueous. It is compulsory to write aqueous. Now, if not aqueous here, you can also write water in or on the top of the arrow. Now, any one is enough. Either write it as AQ here or write 3Br2 and water. Okay, so when treated with bromine water, phenol gives you tribromophenol. Now see, this OH will remain at its position, and on the second, on the fourth, as well as on the sixth position, 2, 4, 6, tribromo, 2, 4, 6, tribromophenol is the product along with 3HBr. In ISC, the byproduct is very important. So, 2,4,6 tribromophenol is the product which appears as a white compound. It's a white precipitate. Okay, so bromination of phenol with bromine water gives us 2,4,6 tribromophenol, 2,4,6 tribromophenol. Moving on, bromination can also be carried out using CS2 or CCl for the solvent in which you dissolve bromine can be carbon disulfide or carbon tetrachloride. Carbon disulfide or carbon tetrachloride can be used. So now let's write the reaction. Phenol plus Br2 in presence of CS2, okay, at room temperature, at almost around 273 to 293 Kelvin, this reaction gives us a mixture of orthobromophenol or 2-bromophenol and parabromophenol. Parabromophenol can also be called 4-bromophenol along with HBr. Okay, so notice the difference in the reaction. Bromination with bromine water gives you a white precipitate, which is 2,4,6 tribromophenol, and bromination with bromine NCS2 gives you mixture of orthobromophenol and parabromophenol. Then comes nitration. Nitration of phenol with dilute nitric acid. Even nitration takes place in two different ways. So when nitration is carried out with dilute nitric acid, that is phenol, and treat this with HNO3 dilute, you will get a mixture of orthonitrophenol and paranitrophenol. 2-nitrophenol or 4-nitrophenol along with water. Byproducts become important even in this reaction. So, if nitration is performed using dilute nitric acid, you are getting a mixture of orthonitrophenol and paranitrophenol along with the byproduct water. Same nitration, if carried out in presence of concentrated nitric acid. Okay, so phenol is treated with concentrated nitric acid, gives you trinitrophenol. Trinitrophenol, that is OH, second position, fourth position, as well as the sixth position, there are NO2 groups. So this is 2,4,6 trinitrophenol, okay, which is picric acid. Picric acid. Along with this, the byproduct is water. That means I need to take 3HNO3. Now, this reaction, though in the heading I've written nitrating mixture, when I explained, I just use concentrated nitric acid. When you use only concentrated nitric acid, you get a small amount of picric acid. To increase the yield of this reaction or the product picric acid, you can use concentrated sulfuric acid also, that is nitrating mixture. Without sulfuric acid, the reaction will take place, but the amount of picric acid obtained will be less. But with concentrated sulfuric acid, you can increase the amount of product, yield of product can be increased. Now, the next reaction is sulfonation. Sulfonation is a reaction of phenol which depends on temperature. So if you take phenol and treat it with concentrated sulfuric acid at around 293 Kelvin, that is room temperature, your product will be OH and SO3H on the ortho position. Along with this byproduct is water. But if the same reaction, phenol, is treated with concentrated sulfuric acid, the temperature is different. 373 Kelvin, that's 100 degrees Celsius. Okay, then the product will be phenol, OH on the benzene ring along with para position having SO3H. So this is a para product at 100 degrees Celsius, and at room temperature, you get the ortho product. Name of the product here, this is orthohydroxy or 2-hydroxy benzene sulfonic acid. 2-hydroxy benzene sulfonic acid, and the other one is 4-hydroxy or para-hydroxy benzene sulfonic acid. 2-hydroxy benzene sulfonic acid and 4-hydroxy benzene sulfonic acid, or ortho and para-hydroxy respectively. The next reaction, which is a very important reaction, okay, we are putting it under the title Special Reactions of Phenol. Kolbe's reaction. Very frequently asked question, Kolbe's reaction. So in this Kolbe's reaction, we need to start with sodium salt of phenol. So the sodium salt of phenol is treated with carbon dioxide at 400 Kelvin temperature and 6 to 7 atmospheres of pressure. 400 Kelvin temperature, 6 to 7 atmospheres of pressure, you will get a product which is a reaction intermediate though. This is O. See, between O and that Na, we are inserting carbon dioxide. O, COO, Na, which is a reaction intermediate. It has a momentary existence. It quickly undergoes a rearrangement. So it becomes compulsory to write this rearrangement, and after the rearrangement you get your phenol OH and here COONA. Okay, COONA on the ortho position. Now that product that we get after rearrangement, okay, that product is hydrolyzed or subjected to acid hydrolysis. This product is subjected to acid hydrolysis. And what you get after acid hydrolysis is benzene ring with OH, that is phenol. Also, on the ortho position, there is a there is a COOH group. There is a COOH group. That is that Na is replaced by hydrogen. So this is orthohydroxybenzoic acid or 2-hydroxybenzoic acid. Commonly, this is called salicylic acid. Orthohydroxybenzoic acid or salicylic acid. So, this question can be asked as, what do you get when phenol is treated with carbon dioxide at a high temperature and pressure? Your answer is salicylic acid. Or else, in MCQs, which among the following will convert phenol to salicylic acid, and what is the reaction called? It is Kolbe's reaction. You need to convert phenol to its sodium salt and then treat it with carbon dioxide. All right, so please note that this is a very frequent question. Next is Riemer-Tiemann reaction. So Riemer-Tiemann reaction can happen in two different ways. So first one, under Riemer-Tiemann reaction, treat phenol with CHCl3 and excess of sodium hydroxide. CHCl3 is chloroform. Okay, so treat it with chloroform and sodium hydroxide at around 340 Kelvin. Your product will be benzene ring with OH and CHO on adjacent position, along with NaCl plus water. Now, this product is called salicyl aldehyde. Salicyl aldehyde, or else 2-hydroxybenzaldehyde. So, how did I convert phenol to salicyl aldehyde? Okay, so in this, phenol is treated with chloroform in presence of excess of sodium hydroxide, and you will get salicyl aldehyde at 340 Kelvin along with NaCl and water. If not chloroform, you can treat phenol with carbon tetrachloride and excess of NaOH under similar conditions of temperature. The only difference here will be, instead of salicylaldehyde, you will get salicylic acid. Salicylic acid. Along with the same byproducts, sodium chloride and water. Sodium chloride and water. Both these reactions are examples for Riemer-Tiemann reaction. Okay, so Kolbe's as well as Riemer-Tiemann are important reactions of phenol. Then we have reaction with sodium. This particular reaction proves the acidic character of phenol. And the same episode now, when we learnt the reaction of phenol with acetyl chloride, okay, we understood that even that reaction proves us that phenol is acidic. Now, let me treat phenol. Let me treat phenol with Na. Okay, so to balance this, I need 2 phenol and 2 Na, And the product that I get will be sodium phenoxide, ONA. This is called sodium phenoxide along with H2, sodium phenoxide along with H2, hydrogen. Okay, this reaction proves that phenol is acidic. However, phenol has no reaction with sodium carbonate or with sodium bicarbonate. Under any acidic compound, we know if one particular compound is called acidic, then it should react even with sodium carbonate or with sodium bicarbonate. But phenol, though it is acidic, it has no reaction with sodium carbonate or bicarbonate. You can expect this as a give reason question. Okay, answer is phenol is acidic. That is correct, but it is a very weak acid. It's weaker than carboxylic acid. Therefore, phenol, because it is very weak, weaker than carboxylic acid, it has no reaction with sodium carbonate or sodium bicarbonate. You can expect this as a give reason question. Then, effect of substituents on the acidity of phenol. What kind of groups can make phenol more acidic, and what kind of group can make phenol less acidic? So, if you have electron withdrawing groups NO2, cyanide, CN, or halide, so on the phenol, on the benzene ring, on the ring of a phenol, if you have NO2 or CN or X, these groups are electron withdrawing groups. They pull the electron pair towards themselves. So what happens? Once the H plus is removed from phenol, that is, once H plus is removed, meaning you have O with a negative charge. You have the oxygen on the ring with a negative charge. But you have a, say, nitro group on benzene ring. So this nitro group pulls the pairs of electron towards itself. Eventually, this lone pair of electron is also moving towards, or it gets dispersed. That negative charge is not remaining there on oxygen. It gets dispersed because of the resonating structures, because of resonance. So, since the negative charge gets dispersed or it's not residing on oxygen, this increases the acid strength of phenol. So, nitro or chloro or cyano group, when attached on phenol or on the benzene ring of phenol, that makes it more acidic. Such a compound will be more acidic compared to, okay, phenol. Then, electron donating groups like NH2, alkoxy group, OR is alkoxy, just R, alkyl, just the OH, one more OH, etc. Okay, so all these groups are electron donating groups. They donate their pair of electron, okay, they donate their pair of electron towards the ring. They push their pair of electron towards the ring. So in that case, what happens is the phenoxide, which already has a negative charge, correct? But because of the presence of these electron donating groups, okay, because of the presence of electron donating groups, the intensity of negative charge on oxygen of phenoxide increases, because of which the acid strength of phenol decreases. Okay, so this can also be asked as a give reason question. Is phenol more acidic or nitrophenol? So the answer is nitrophenol is more acidic, or is, presence of an R group on phenol increases or decreases the acidic strength, and why. So the whole thing has to be studied and reproduced the same way. Now, the last part is test for phenol. That is, a compound is given to you. You need to check whether it is phenol. So, phenols react with neutral ferric chloride to form a violet-colored complex. Phenol react with neutral ferric chloride to form a violet complex which is soluble in water. So this doesn't mean that none of the other alcohols will react with neutral ferric chloride. Almost, a lot of compounds react with neutral ferric chloride, but the color of the complex will be different. Phenol gives you a violet water-soluble complex. This is a test for phenol. Another test for phenol is the azo dye test. This goes under coupling reactions. Now, in presence of ice cold solution of benzene diazonium chloride is to be treated with phenol in presence of a base. Ice cold alkaline solution of benzene diazonium chloride on treatment with phenol give bright orange colored dye due to coupling reaction. Okay, so here the reaction is benzene ring, and from the diazonium chloride, the Cl minus part and the para hydrogen which is present on the para position, that combines with the Cl minus. So your byproduct here is HCl. Along with this, you get your benzene ring. This is from the diazonium chloride. Then N double bond N. Okay. And that is connected to the phenol part. It is compulsory to show this N double bond N. You cannot condense and write this as N2 in ICSE corrections. This is checked. Presence of double bond has to be written. And this product is called para-hydroxyazobenzene, which is an orange dye. Para-hydroxyazobenzene, which is a orange color dye. So this is the coupling reaction, which can be taken as a test for phenol. There are several other compounds which answer this test, but only phenol gives the orange color. Okay, that's all for now. Stay tuned for more videos. Thank you.